Hello everyone, I am Atikur Rahman and welcome to my class. Today I'll be teaching Coulomb's law of electrostatics. Now, before going for the derivation, you need to understand what Coulomb's law talks about. Coulomb's law talks about the force between two point charges. Say if you have one point charge q1 which has a charge q1 and another point charge which has charge q2. The force between these two charges, the Coulomb's law provides us the force. This force, it might repel if there are like charges plus plus, then of course they will repel, you know this. And if there is a plus charge and there is a minus charge, then they will attract each other. So all of this force is given by Coulomb's law. So let us see what Coulomb's law states. This is our system. If we have a system of q1 and q2, this is a point charge and this is another point charge separated by a distance r, and this has a charge q1, this has a charge q2. Now Coulomb's law of electrostatics states that if two point charges are separated by some distance, then the force on each of the charge, as I have mentioned above, that if two point charges are separated by some distance, then the force acting on the charge is proportional to the product of the magnitude of two charges. So this force will be proportional to the product of charges. Product of charges will be nothing but q1 into q2. And secondly, is inversely proportional to the square of distance between them. F is inversely means you will have to take 1 by something. Inversely proportional to the square of distance. So we have the distance, a distance of separation r, so it will be the square of distance. So F is inversely proportional to 1 by r square, as I have mentioned here. Thus mathematically we can write F is proportional to q1 q2 and F is proportional to 1 by r square from this one and this one. So you have got this, and then we can combine this. As both of these are proportional to F, we can also write F is directly proportional to q1 q2 by r square. Q1 denotes the charge of our charge of this body, and q2 denotes the charge of this body, and the r depicts the distance between them. So F is proportional to q1 q2 by r square. Now if we remove the proportionality sign, we get a constant k. So F is equals to k q1 by q1 q2 divided by r square. Again, now we have the value of k, which is equal to 1 by 4 pi epsilon naught. Now you might be wondering what's the meaning of epsilon naught. Epsilon naught is nothing but permittivity of free space. Now what does permittivity mean? Permittivity is nothing but the ability of a substance to store electrical energy in an electric field. See, we are conducting let's say we are conducting this experiment in free space, so we'll have to take the permittivity of free space, right? Means how much the free space can store electrical energy. That's given by epsilon naught, which is the permittivity of free space, and we have the value of permittivity of free space, and putting all together we have the value 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught equals to k equals to this is the value 9 into 10 to the power 9 Newton meter square Coulomb to the power minus 2. You have to remember this value, as this will be used in further numericals, so you need to remember this value. Also you can also write the force like this: F is equals to 9 into 10 to the power 9 Newton meter square Coulomb minus 2 q1 q2 by r square. As we have found out the value of 1 by 4 pi epsilon naught to be this, so we can replace it here and we can write this is the Coulombic force between two body. As we are taking the charge of two bodies q1 and q2, so this will be the Coulombic force between two body. These are our two bodies separated by distance. This is q1 and this is q2. I hope you're clear with this.
Now you might be wondering, as we are calculating the force, so we should get its SI need to be in newtons, right? We're calculating force and we know the SI unit of force is Newton, but we are getting here Newton meter square and c to the power minus 2. See, what's interesting here is this: the force equals to 9 into 10 to the power 9, which is a constant, which has come from here, and Newton meter square c to the power minus 2. this is the value of 1 by 4 pi epsilon naught. And we have, see, the charge of q1 is the charge and q2 is also a charge, and SI unit of charge is denoted by Coulomb, which is C, and q2 has also a charge and its SI unit is denoted by Coulomb, which is C. So if you take the magnitude q1 q2, only the magnitudes, and it will give out a C square. This both C into C will become C square, right? And then below we have R squared, and for R the SI unit we know is meter, so for R squared we will have meter squared, so it will be R square into meter square. So this meter square and this meter square cancel out, and C to the power minus 2 and C square cancel out. You do know how to cancel out, right? What does C to the power minus 2 actually mean? It's nothing but 1 by C square. So here is 1 by C square. This and this cancel out, and we get 9 into 10 to the power 9, which is a constant, q1 q2 by R squared. The values, we have to put the magnitude here, and then we'll get a Newton, which is the SI unit of force.
Now, in order to make concepts clear, I have chosen numerical. So the question is, two like and equal charges are at a distance of d equals to 5 centimeter. D is the distance between them. So the distance is 5 centimeter and exert a force of F equals to 9 into 10 to the power minus 3 Newton on each other. Find the magnitude of each charge and what is the direction of the electrostatic force between them. This is the question. So let us move to the solution. Two like and equal charges, okay. Now from Coulomb's law, we have F is equals to 1 by 4 pi epsilon naught into q1 q2 divided by R square. Now as we have two like and equal charges, we have equal charges and they are also like, so we can take q1 and q1 equals to q2 equals to q, as they are like and equal. So we have q1 equals to q2 equals to q. So now we will have F equals to 1 by 4 pi epsilon naught q into q divided by R square. So F will be nothing but q square divided by 4 pi epsilon naught R square. Now we just have to put the values given d equals to 5 centimeter and d equals to R here. So we have d equals to R equals to 5 centimeter. Now d equals to 5 centimeter, as we have the distance in centimeter but we know the SI unit is in meter, so we'll have to convert it to meter. So we'll just divide it by 100, so we'll get 0.05 meter. This is our distance, 0.05 meter. So now, and we have q. No, we do not have the value of q, we have to find q. And we have force equals to, force is given 9 into 10 to the power minus 3 Newton. So that's given 9 into 10 to the power minus 3 Newton. Okay, so now putting all the values in our initial equation, we'll have value of force is 9 into 10 to the power minus 3 equals to value of 1 by 4 pi epsilon naught 9 into 10 to the power 9 into q squared divided by 0.05, which is the distance squared. So we can easily cancel out this and this 9, and we get q squared equals to, this will be 10 to the power 12, 10 to the power minus 12 into 0.05 squared. So q squared equals to 0.05 squared into 10 to the power minus 12.
And removing the square sign, we'll just get q equals to, we'll just take the square root. So square root of 0.05 will be 0.05 square will be nothing but 0.05, and 10 to the power minus 12 will be 10 to the power minus 6. As you know, square root is nothing but to the power 1 by 2. So 10 to the power minus of 12 into 1 by 2, you will have to cancel out this, so it will be 10 to the minus 6. So this is the value of our charge, and we take charge in coulombs. So we have Q equals to 0.05 10 to the minus 3 coulomb. This is our value of charge. Now moving on to the next part of the question, we have what is the direction of the electrostatic force between them. They have already mentioned that two like and equal charges, and let me demonstrate it once again. I have already said that for equal charges, say both of these are plus, then they will repel each other. They will repel each other, and if the charges are plus and minus, they will attract each other, right? So here, as they have already mentioned that two like and equal charges, so they are like, so both of them are either both are plus or both are minus, but in either case they will repel each other, so the direction of force will be repelling in nature. That's the answer of the second part of the question. Hope you like it.